most of the product in the market, you have a power line communication that is for PLC rapid shutdown. In Tigo, we also have a wireless communication device, but that is offered in addition to rapid shutdown, also with the module level monitoring and the optimization.
We have this thing called rapid shutdown in the solar industry. With the advent of the NEC 2017, that's the National Electric Code, some solar arrays are required to incorporate what's called rapid shutdown. And this is a safety feature for especially first responders, but for all of the solar industry, this is a safety feature. My guest today is Jing Tian. She is the Chief Growth Officer for a company called Tigo. Welcome to the show, Jing.
Yeah, thanks, Tim. I really appreciate the opportunity. Thank you.
It's always great to have such industry veterans on the show. You have such a wealth of experience. You've been in many aspects of the industry. And so for our listeners, please give us a little background on yourself. How did you get interested in energy? Why did you end up getting a PhD in some exotic science and then get into industry and not academia?
Oh, that's a very good question. I think I got a PhD in chemistry, but what I really did was solid state polymer materials. My dissertation was in organic conductive materials. That's very naturally ties into the application of batteries and the photovoltaics. So I get exposed to these aspects of research while I was in graduate school. So I always thought it great to watching the PV industry growth from the early days of $10 a watt to today's price of cost less than 30 cents a watt.
Yes.
So this is like a really interesting, exciting industry. I just want to see a product to translate it into a real application. That's why I pursue the industry rather than academia.
Very good. And you've worked at several very noteworthy companies. Give us a little background on the companies that you've been part of and now with Tigo. So tell us a little bit about that.
Yeah, it's a journey. I'll start out with a company called SoFocus. That is a Silicon Valley startup. We start out as a concentrated photovoltaics. Early days, if those of you remember, when the silicon wafer was still very expensive. So one of the way to reduce the PV cost is to use a mirror to replace the silicons. So that was the premise of the concentrated photovoltaics with a 3-5 junction semiconductor. And so you can use much less areas of semiconductor concentrated solars into 5x of a solar irradiance to produce more energy. So that was the early days. I was there for 4 years. Then the silicon wafer price coming down significantly. Then it gets very difficult for the mirror to competing with the silicon. So silicons just scale a lot faster. So then I went to nano solar. So that was a printing thin film technology on the flexible matrix. Again, early days, there's a lot of technology. People are looking at different ways to bring the PV cost down, right? So it's CPVs, concentrated, the thin films, and the silicon. I think in the end, obviously, we all know today, silicon still is the king of the PV industry. So I went to Trina Solar. I was there for quite a few years, took on different roles at global marketing, as well as responsible for US business there. Then, I went a few project developers, and also went to some help with the inverter companies. And then I joined the Tigo.
And Tigo is a power electronics company, which is extremely important now when we have this phenomenon called rapid shutdown. why don't we just start at the top? What is rapid shutdown and how does it work?
Yeah, rapid shutdown is an electrical safety requirement, as you mentioned earlier, Tim. So what does is it de-energizes the PV array when it's needed, right? So it's mostly accomplished with some sort of module level power electronics in order to comply with NEC code 2017 and 2020, because it requires at the module level voltage to go down less than 80 volts within 30 seconds. So then typically the MLP is installed on the back of each module. Then it communicates with the inverter. So this setup allows the photovoltaic system, by using directional communication signal to the inverter. Then when the presence or loss of those communication signal acting as on and off switch. So only when the shutdown initiated, in other words, when sending a signal or lost the signal, then tell the PV array to go down to shutdown mode, then the system gets into shutdown. So create a safety for firefighters and the emergency people need access to roof.
So these MLPEs, module level power electronics, are a small box that sit connected to the solar module. They're typically 1-to-1 or 1-to-2, meaning one MLPE per two solar modules, depending on the configuration, depending on the product, depending on the approach. Different manufacturers have different approaches. And but at the end of the day, right, you just said it, it's a switch, right? It turns off the solar module and prevents the electricity from running from the solar module to the facility. And so the entire system gets de-energized very quickly. And this makes it safe for things to happen like axes to fly and cut holes in roofs that might be covered with solar arrays so that the firemen can do their job, which is to create a vent so they can get smoke out of the building so that they can do their job and save lives and not be in harm's way themselves, right? We don't want anyone to get hurt when there's an emergency. And so this is a fire safety phenomenon and technology at the end of the day, first and foremost. Mm-hmm. And it has pros and cons. It does, in theory, create a safer solar array, which we're very fond of. We want solar to be a safe technology for everyone involved. And, electricity is dangerous. So there's no ands, ifs, or buts about that, right? We have to be honest. Electricity is dangerous, potentially, but it is a necessary thing, right? We can't have the modern life that we have without electricity, and we can't have a clean grid without solar. So we need these solar arrays on our rooftops. And so we're grateful for all of the, scientists and engineers who are inventing these wonderful devices. So let's go a little deeper. And I think I've explained why we have rapid shutdown, but is there anything else you want to say about why rapid shutdown is important?
Yes, I think you covered it very much. I mean, it's intended to protect the firefighters and the first responders from contact to high voltage electricity. Keep in mind, even if the PV array under the sun, they are activated. Even if it's not producing, the AC electricity, say, for example, you don't have a load, but the PV array is still energized. That is important to remember. So that's why I need a rapid shutdown to protect them so they can go in there to do the job they need to do, or do not watch the house on fire because they cannot reach access to the roof because the high voltage hazard. Yeah.
And so what is it that triggers a shutdown event?
At the module level, power electronics usually is two ways to do it. Usually is either you go through a hard button. It's what we call as emergency stop button. At that point, usually sending the signal to each module level power electronics on the module, and they say, here's the event. So you're going down to shutdown mode, which technically is to prevent module to continue to output the current and the voltage. Right, so it's at each module level, you shut down the current output, so that therefore it gets the system safe.
And
the other mechanism is usually grid auto detection, right? So you detect a grid off from the inverter, then sends the signal. So oftentimes those two are combined to use in the both case, especially as more and more people adopting the battery storage system, right? Grid off doesn't mean you need an anti-rapid shutdown. So it's oftentimes, in this case, is both physical as well as auto detection going on in combination.
yeah. So let's talk about a specific case. Let's say that there's a short happening in a solar array. Some connection is getting hot or sparking or doing something it shouldn't do. And the MLPE notices this event, and then it sends a signal using the very wires that are sending the electricity, right? This is power line communication, or PLC, as you call it, right?
Yes.
And how exactly does that work? And is that a state-of-the-art technology?
I think this is one of the most commonly used technology called power line communication. Essentially, you're sending a signal. I usually could say, a special signal to each module power level module electronics, and the module level power electronics. I don't know. So what does is hear the signal. So it say like, okay, the signals are here, so I'm keep it on. So when that signal disappear, then say, oh, signal is not there. I need to enter into shutdown mode. So that's how it is communicated.
Hey, everybody. Thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and review. Back to the show.
And what else should we know about rapid shutdown? It is, in my mind, okay, rapid shutdown is a safety feature. And so I immediately go to things that could go wrong with solar arrays. We don't like to talk about this in the solar industry, but solar arrays do catch fire. There are things that go wrong with solar arrays, but what else should people be thinking about when it comes to rapid shutdown, and how is Tigo, I guess, approaching this problem from a high level? And then let's get into some of the nitty-gritties.
Okay. Let me just make sure I understand the question. It's like really how can rapid shutdown technology used, or if you can clarify the question, if you don't mind.
So, I mean, we've touched on, okay, we have this thing called rapid shutdown, and the MLPE is integral to this. The MLPE is a technology that allows for rapid shutdown. There are other ways, right? You can put the inverter very close to the array and use the inverter without an MLPE, but in large solar arrays, that's not practical sometimes.
Yes.
And so the MLPE approach is a widely adopted approach. But if you're a solar installer, or you're doing O&M, or you're a developer, I mean, there are many angles to the solar industry. But if you're a solar professional, what do you need to know about rapid shutdown that you may not know already?
Oh, that's it. Yeah, so rapid shutdown, there's I can't speak for every other product, right? But most of the product in the market, you have a power line communication that is for PLC rapid shutdown. In Tigo, we also have a wireless communication device, but that is offering addition to rapid shutdown, also with the module level monitoring and the optimization. Since we are talking about rapid shutdown specifically today, so I will focus on the PLC communication. So which is really, really important as designing the systems, be really aware of the phenomena, what we call it is a crosstalk, right? So this is not the Tigo product specific. This is like anyone use a power line communication. Then when you have two conductive wires adjacent to each other, the signal could jump from one wire to the other wire. So that's what we call the crosstalk. So hypothetically, as we speak earlier, Tim, we say how is the signal is generated. So like signal generated from a transmitter, then sending the signal down one power line to the module level power electronics. So they hear the signal, they're out. They don't hear the signal, they're off. If you have another line next to each other, but the line is supposed to be down because it did not hear the signal. But if there's a crosstalk, then signal jump into the next line. So then the other array is supposed to be off, end up is on, or some on, some off, because the crosstalk, the signal integrity is not so great. That will cause some problems for the entire system.
Yeah, I'm curious. You know, when a solar array goes into shutdown, then it has to at some point come back to life. What is the process for figuring out what's going on? Do you have to roll a truck, or is there a remote monitoring feature, or what? Walk us through that process from, you know, when there's a yellow alert and the MLPE goes into shutdown to then coming back to life, because there's false positives, there's true positives, and then maybe somewhere in between. Yeah. But what are some of the scenarios, and how do you approach this?
Yeah, so with the Tigo TS4F family product, right? So as I mentioned, that the rapid shutdown is triggered by two things. One is the loss of when you detect the AC grid off, then enter into rapid shutdown, then AC grid is back on, then the system will go back into the operation mode. But if it's triggered by the emergency button, then you have to go in there manually. Like oftentimes there's someone there to push the button, then you'd be at the job site to bring the system back on. But oftentimes, if it's a true rapid shutdown, you probably want to inspect the system to bring back up, right? Mm-hmm.
And then the technician doing the O&M, though, they would have some specific information about where the problem occurred, right, within the array. They actually would be able to look on their smart device and identify a specific region of the array, and they're not just, it's not a needle in the haystack problem, really, right? It is quickly identifiable where the problem occurred, right?
Yes, that's where the Tigo TS4 AO and the AS. So Tigo, that's the reason we call it TS4 is because we have a very flexible product to offer with a different type of functionality, right? With the TS4 AF is for rapid shutdown only. We don't have that ability to pinpoint where the problem is. But if with the Tigo TS4 AO or AS, they both offer module level monitoring with the O adding additional function for optimizing. Then we have a module level monitoring portal. You actually can see details of what's going on with each panel, what's going on, can very quickly help people identify where the problem is. And then also we talk about the remote access that reduce the truck roll significantly. I mean, we can diagnose more than 97% of a problem remotely and then resolve those problems remotely.
You know, in your materials, you identify that one of the causes of PV-related fires is improper mating of dissimilar connector types. Mm-hmm. What are you referring to when you say dissimilar connector types?
It's two different type of connectors, say, MC4 connectors with the H4 connector, for example. And it's not obviously this is a pretty lengthy, it's a pretty passionate topic for me about the industry needs to standardize rather than each one has a different type of connector with NEC code require has to be same type of connectors that, it's very inefficient. But that said, because this is different design, right? So could be cause the connection gap and or not connected properly. That's where oftentimes with the arc of with initiation of the fire happens.
Yeah, rooftop fires are no good for anyone. They're not good for the host. They're not good for the solar installer. They're not good for the solar industry, right? We don't like fires.
Nobody likes it.
and there have been a number of high-profile solar fires in the last couple of years. But we have to remember they're a tiny fraction of the solar installations. Solar is a very safe technology, generally speaking. I do want my listeners to understand this. You should not be afraid of installing a rooftop solar array. You want to work with qualified professionals who are very experienced, who use top tier products, right? You don't want to chintz on your solar products. And so this is very important. You don't want to just install the cheapest equipment possible. And but when it comes to, installers face many challenges. Sometimes the modules don't come with long enough leads, and so you have to install extra wire and extra connectors to make the solar project work. And sometimes there's a shortage of MC4 connectors by a single manufacturer, and so you have to work with multiple manufacturers. I mean, there are these practicalities that you can't just snap your fingers and be done with. It is a slightly complicated situation, but anyway, what else should our listeners know about Tigo? You have a family of products. You are making a best of breed technology, but it is there's a spectrum. So what do you have to say to those project managers and procurement professionals who are specifying your technology? What do they need to know about Tigo?
I think it really, it's a very good point. And thank you, Tim, about fire, right? So we, there's a small amount of incidents, but one fire is a fire to a customer. So I think we don't take this very lightly. But in the case of where the system causes fire, it's oftentimes I don't want to make any assumptions, but in a lot of cases, what we see is not a component from Tigo's product perspective. It's not a Tigo component to cause problem. A lot of it is to do with the design and the implementation. And we view it will be to an industry benefit for everyone to understand ways to install module level power electronics with PLC communication. So we've taken a multi-pronged approach to bring the industry forward to get more educated. So what we did is we had quite a few things we've done. We've first is updated the documentation and installation guidelines to really help people to understand crosstalk and how to avoid it, right? So what we call crosstalk avoidance criteria. And so those, and we have lots of white paper available on our website. In addition, this year, we also released the PLC signal integrity tool that is applicable to anyone's inverters, devices. It's really helping people to diagnose potential crosstalk issues, either from design phase or from the system you already installed. So if you get a green lights, meaning you are okay. If you get yellow or red, we ask people to contact us. We can help you to take a look, figure out how to mitigate that, right? Then also early in June this year, we have released Tigo TS4 certification course to really help educating people. It's a self-paced learning, and it also has the it's a NABCEP credit as well. And most important, the other thing is, in addition, we also we're about to release a NABCEP crosstalk workshop with the Mayfield Renewable. It's really in the interest of to help the entire solar industry community. So that's what we do for help people understand the crosstalk. But on the other hand, we also continue our innovation that is rooted in Tigo's blood. All right, so we introduced what we call the pure signal technology transmitter not November, so actually early in the summer. It's really help people, if you wanted to put a signal together, this is the technology to help you to mitigate it even further. And so I call the last line of defense for the combat the crosstalk phenomena when people want to put a wire together, home run together, to help people to simplify the installation.
So you mentioned a partnership with Bayfield. I mean, I'm on your website, tigoenergy.com. You go to the resources tab. Where can people find out information about these webinars that you're giving?
I think it's all on the resources website, and I think the Mayfield is not released yet. It will be released as a part of NABCEP curriculum. Yeah,
I see. Gotcha. Good
yeah, will be delivered in person at the next NABCEP conference.
Okay. Yeah, that's coming up, I think, in the spring in St. Louis, if
That's right.
recall correctly.
Mm-hmm.
So great. So anyone pursuing NABCEP certification or recertification, just take note that you can learn about Tigo and earn CEUs. You can find many CEU courses, including my own, at heatspring.com. So check out heatspring.com. And I have 2 courses there on commercial solar, one on de-risking those leads and projects on the front end, and then a full 5-hour course on selling and developing commercial solar projects. So check that out. Well, Jing, I don't really have any other questions for you. What else would you like to talk about, if anything? I really appreciate you coming on the show. And I mean, I know Tigo's really keen on this issue of crosstalk. I don't fully understand, I guess, what the problem is. If you want to say more about that or anything else, feel free.
No, I think, I'm covered most of it. I think, one last point is I forgot to mention is Tigo has a very rigorous quality control, right? So we have continued to improve our product, and we have the total improvement over the years. We have shipped 10 million TS4 units since 2016 with our return rate at 0.01%. Right, so we are continuing to drive this. All our products are 100% tested out of factory, we did, in the industry, people did hear some of issues, as I couldn't emphasize this enough, is to do with how we install, how we implement the system. So if people with any questions, I would love for them to check out our website, come contact us, learn more about how to best to install, implement the Tigo devices in the field.
Yeah, I love it that you have so much educational content on your website. I really appreciate that. This is a very fast growing industry. We are now growing between 40 and 60% a year, right? We were doing about 40%. Now we're going to ramp to 60% a year. We're going to triple in the next 5 years. We're here in 2022. And this is a combination of what's going on globally in clean energy, but also the IRA legislation, the Inflation Reduction Act. I guess that is a question. One of the bottlenecks is supply chain. How is Tigo tackling supply chain issues? Because chips are in short supply. You yourselves are making a computer on a box that sits on a solar module. So What do you say about the supply chain challenges?
We fortunately have managed our supply chain. We very strategically work with our supply partners. We have no issues to meet the demand in the market. We'll continue to be able to supporting the industry growth. We have growing the business multifold this year, be able to meet the delivery need. I think I'm looking forward to grow with our partners, installers in 2023.
Very good. Well, check out all of our content at cleanpowerhour.com. Please give us a rating and a review, most importantly, a review on Apple and Spotify. And please subscribe to our YouTube channel. Just click on the YouTube icon there at cleanpowerhour.com and check out my courses on HeatSpring. I'm Tim Montague. Let's grow solar and storage. Thank you so much, Jing.
Thank you, Tim.